Welcome back, participants. Now, moving forward, moving forward, we move to the second technical session of the day, which will be conducted by Professor Ritesh Banpurkar sir. Professor Ritesh Banpurkar is an assistant professor in the Mechanical Engineering Department at Tulsiramji Gaikwad-Patil College of Engineering and Technology, Nagpur, Maharashtra. He holds a Masters of Technology degree and has been serving in his current role since March 29, 2014, accumulating over 10 years of experience in mechanical engineering design. In addition to his teaching responsibilities, Professor Banpurkar serves as a Dean of Internal Quality Assurance Cell (IQSC) and Head of the Department of Mechanical Engineering at TGP-CET, Tulsiramji Gaikwad Patil College of Engineering and Technology, Nagpur. His research interests include mechanical engineering design and he has contributed to the academic community. Till now, he published more than 15 research papers in Scopus and UGC Care journals. He has patent published 3, copyright published 3, and 1 book published. He delivers FDP session in various faculty development programs on topics like outcome based education, preparation for NAC, 3D printing technology, etc. Recently, he delivered a presentation on faculty development program exemplified by his session on ethical consideration in AI conducted on November 28, 2024. Now, I request Professor Banpurkar to share their valuation insights with us. I am going to hand over the session to Professor Ritesh Banpurkar.
Thank you, Saira ma'am, for a introduction. At the outset of this FDP program, I would like to congratulate a Data Science Department and Turchiramji Gaikwad Patil College of Engineering for hosting such a wonderful faculty development program, ATAL sponsor faculty development program. So now I will proceed with my presentation. Screen is visible to all of us. Hello.
Yes, sir.
Okay, thank you. So our today's topic is uh, le- leveraging machine artificial intelligence for ethical consideration in generative AI and data science for healthcare. So in our today's session, we will discuss about the generative AI. What is the concept of generative AI? How generative AI evolved? What are the various basic models involved in the generative AI? And how all those models are helpful to healthcare domain for research and development. So, in this today's session, we will explore the various opportunities of research for the budding engineers or faculty members to pursue a research in this emerging domain. So, talking about the generative AI is nothing but the branch of computer science. If we consider a branch of physics, physics having a multiple domain like thermodynamics, deal with the heat transfer. Same way, if we discuss about the computer science having a branch of artificial intelligence. If you more explore AI, then AI having a subset of ML, machine learning. And if we again explore more about the ML, machine learning having a subset of deep learning. And if we again explore a deep learning, then we come across the term generative AI. Normally, we are using nowadays in our day-to-day working as a chat GPT. So, what is meant by generative AI? So generative AI is nothing but generating new content in term of audio, text, code, image or video by using computer programming in a automatical way on the basic concept of dealing with unsupervised database. In generative AI, we are not working on a supervised database generally considered as a label database. In generative AI, we work on the data set that is unsupervised to get a more result in an unsupervised manner like a summary of anything, or if we have any imagination we can generate the image from that, or we are not able to generate a code we can generate a code. So in generative AI, we are generating our conceptualizing things by using existing various models of our artificial intelligence domain. If we consider talk about generative AI, AI having a various application in our day-to-day life, and for dealing with that application, generative AI use various parameters of computer science and engineering. Like generative AI is a subset of artificial intelligence. Generative AI work on unsupervised learning algorithm. Generative AI generate realistic data means just by imagination. If we are putting some imaginary uh, queries over there, then that generative AI able to generate such data or such images. Generative AI help for creating new content or developing much more things. So generative AI is not a new term in a computer science and engineering domain that was evolved from early of 19 or before that, but not up to that extent. If we talk about generative AI from 2000, we come across the various experimentation done by our researcher, and first thing what we use for generating a new concept is a good translator. If we want to translate anything from English to Hindi or any other language, so we use AI term over there, but that is not a generative AI, that is we consider it as a artificial intelligence. But if we see the shift of artificial intelligence after 2018, there is a tremendous shift in the use of our AI in term of generative AI for creating innovative thing or develop the innovative things in our day-to-day life. So nowadays, generative AI is nothing but a machine learning model. Generative AI work on various machine learning models like LLMs, language learning models, then generative adversarial network, and lot of models are there for the use of generative AI and the development of a generative AI or exploration of the generative AI. And if we talk about the key capabilities of generative AI, as I already told to you, it's not for the use of text generation, image generation, audio, music. We can develop anything by using generative AI in our day-to-day life because that's sector has a huge expansion and lots of research has been already done in this particular section. Now, for the development of generative AI, we have to understand what are the foundation models, because if we are not able to understand what type of foundation models are used to develop the generative AI system, then we are not able to understand generative AI in a real term. So, if we discuss in a broad term, generative AI is nothing but a combinations of various foundation model is used for the generation of a new content or innovative content. So, in simple language, foundation models means what? Foundation models are a huge neural network architectures that are trained on a massive data to solve a particular problem or a task. Means if we want to solve any task, and if we want to solve any task, to solve that task, if we are providing we have a one architecture, and we have to solve a one problem by using that architecture or basic model. So what we do, we give a lot of data for the training of that architecture, and based on the training of that architecture on a given data, we are able to solve a task. In early, there are classification tasks are given to the architectures available in our computer science sector for the classification. If we give an image, we ask that architecture whether that is the image of cat, or what that is the image of dog, or any other fruit. So when we teach that architecture by giving a ample of data, then only that architecture is able to give a proper solution to our task. What for what task we are learning that architecture on the database. So foundation model is a nothing but learn architecture uh, to solve the particular task or specific task. So if we see foundation models having a three important part. Number one is the architecture, number two is the data, and number three is the task. If we talk about architecture having some importance parameters, or architecture must have some important properties. Number one, architecture must be a huge. So whatever architecture we are developing, that architecture having a n number of neural network inside that architecture. Because if architecture is not huge, having a not having a number of n numbers of parameters or n number of neural network, then that architecture is not capable to solve a specific task. If we correlate that term in term of biology, if we consider the brain of small ant, and if we consider the brain of human being, or if we consider the brain of any small animal like cat, and if we consider the brain of human being, so what's the difference between both the brains? In biological term, if we broadly or simple way, if we see, the brain of cat is small and the brain of human is big. That's why humans are capable for solving a multiple problems and give a proper solution that problem, instead of giving of any animal brain, if we consider it simply in term of biological way. Same way, the architecture is huge, then that architecture is capable to solve n number of problems. That's why architecture must be a huge. Then second property is scalable. Whatever architecture we are using for the development of generative AI model, that architecture must be scalable, means multidimensional. That architecture capable to solve a with n numbers of problem, not for a specific problem. For example, if we learn architecture to architecture is capable for only developing captioning to image. So that is if that architecture is only capable for captioning the uh, picture or summarizing the any data what we are giving to that architecture, then that architecture not capable to develop a multiple research. So that architecture must be scalable, that architecture must be able to perform n number of tasks. And then last one is the state of art architecture. Whatever architecture we are developing in generative AI, that architecture have a state of art facility, means that architecture capable to develop a very precise quality wise result in term of output, then only that architecture is usable. So in general there are n numbers of architectures are used for the generation of the foundation model, like transformer based architecture, GANs model, encoder decoder models, or encoder decoder architecture we use generally for the development of foundation model for the generative AI. Then we have a architecture, but second important parameter of that foundation model is data. If we have a huge architecture, but that architecture is not trained on a multi-dimensional database. Suppose we have a one architecture and we train that architecture by giving only data of movie related data, so that architecture are capable to give answers of the what are the various types of movies, what movie get uh, when that movie get published, or whatever it may be. If we train that architecture on multi-level domain, that architecture train on the data of medical, that architecture train on the data of Wikipedia, that architecture train on the data of movies or n number sports data, whatever data available in our domain, we train that architecture on that data, then only that architecture are capable to generate a bias result, good result, diverse result, and that result having a good modality over there. And if we train that architecture on a massive database, then only that architecture is capable to do a desirable task. Some in earlier days, whatever architectures are developed, that are very uh, specific domain specific task specific architectures are developed. But nowadays when we are using generative AI, or in simple way chat gpt, chat ChatGPT is not there for develop a specific domain specific result. ChatGPT is not giving only a data for means the ChatGPT is not capable for writing not only for the application purpose. If we ask ChatGPT what is the symptoms of disease, ChatGPT is capable to give that results. And because of that symptoms, ChatGPT also generate which disease is there. If we ask ChatGPT about the information of anything in the world, ChatGPT is capable to generate that results also. In previously, such things are not there. So, in nutshell, foundation models are a huge neural network architecture trained on a massive database to solve a problem or particular task. And if we considered why that how that foundation models get developed. So to develop the foundation models, there are three stages. Number one stage is the pre-training stage. Number two is the alignment stage. Then number three is the fine-tuning stage depending upon the task, means whatever task we want to do, we have to do a fine tuning. For example, if we take any basic model, architecture model, and we train that model how on the language parameters, means what are the basic concept contents of language, how language is developed, what are the meaning of various words, and n number of things about that language. So architecture is trained on that particular language model. So pre-training stage is completed over there when we learn that or teach that architecture about the data. Particularly, I am just putting an example, language related data. So that architecture is capable for generating the summarization of data, next word prediction data, or giving a information about anything. But sometimes what happens when we learn teach that architecture on a language based data, if we ask any question to that data, sometimes there is that architecture not giving a proper answers over there. So alignment is required there, and for that we use RLHF model, means reinforcement learning based on a human feedback. Means in next stage human will decide the what answers is given by that particular model is right or not. According to that, human will interfere in that and correct the feedback of that output, and alignment is done in that particular time. And last step come across is there, fine tuning upon dependent upon the specific task. So if we want to develop a chat box for our business purpose. So if someone having a business of spare part, so there we here it comes is a final stage, that is a fine tuning test depending upon the task. So whatever questions asked by our customer, we train that model on that specific questions of customer, and then that complete model will develop, and that model is used for the application, whatever application we want. Just now I said take an example for the spare part business purpose. So in such a manner the training of any foundation model done in three stage. Number first stage is the pre-training stage, second stage is the alignment stage, and last stage is the fine tuning stage depending upon task specific. So if we see the foundation models and types of foundation model, so foundation models are broadly classified into four categories. Number one is the language based. Number two is the vision based. Number three is the multimodal, means combination of both language based and vision based. And number four is the domain specific. If we talk about language based models, so language based models are capable for the text generation, classification purpose, summarization of any data, or for question answering. And if the practical example of language based model is a chat gpt or gemini, we can consider it. Then if we consider the vision based foundation model, and if we are developing a app by using vision based foundation model, then vision based foundation models are capable for generation of image generation, answers from that images, what is the image, what give the briefing about that particular image, means visual question answering, image segmentation, and detection. But in some time in nowadays, from the one model we want both the parameters. That model must perform a language based and vision based both things over there. So chat gpt having a latest versions of dal e, here we can develop images ppts by using that multi-model foundation model, having both the combination of language based and vision based. But as today's topic is related to healthcare, if we ask anything to existing model, whatever we have example in term of chat gpt, give a specific answer. If we ask him about the sports domain, prediction, whether according to pitch report, if we ask that chat gpt whether the run whatever run scores are there, depending upon the previous performance of the player, which team will win the match. So ChatGPT is not capable to give answers of such question, because ChatGPT is not trained on that database. Means ChatGPT is not a domain specific. So same way, if we are developing some model for healthcare, if we give a symptoms of that particular model, that symptoms of disease to chat gpt not give correct answers to us. This is the exact disease you have, and these are the remedial thing you have to do, because that ai model is not learn on the specific task for the medical purposes. So there are some specific domain specific models are available in nowadays, particularly. But if we considering our computer domain, codex is there. Codex is capable for generating the codes, various codes of our computer domain. Again, if we consider the one more domain specific model is Bloomberg GPT. That Bloomberg GPT is particular for the finance domain. So Bloomberg GPT is capable to give answers regarding to finance domain. So in nutshell, there are basically four types of foundation models are there, and based on that foundation model, n numbers of models are generated or developed nowadays by doing more explorations of research in that particular term. So today we are discussing about there are n numbers of model, but as per the time constraint, we are only taking a review of a language-based model, that is a LLM, large language model. So large language model work on a sequence to sequence modeling. If we are seeing the basic concepts of deep learning having a various types ANN, CNN, RNN, then sequence to sequence modeling, and last one is nowadays most commonly used the learning on the unsupervised database, that is nowadays using in our GPT application. So large language models are work on a sequence to sequence modeling. So if we consider sequence to sequence modeling, so sequence to sequence modeling work on the basic concept of RNN, and there are various five types of RNN network. Number is one to one, number two is one to many, number three is many to one, number four is many to one. So one to one is a very simple. If we talk about RNN model, one to many example is the image captioning. If we are giving one image, we can generate many output from there. We can ask for the captioning from that image. We can ask for the description of that image. So by giving one input, we can capable to generate many outputs. Sometimes we have a many output, but we can generate a one output, that is many to one, means sentimental analysis. For the example, if we are that model is trained on the movie reviews. If we give a movie's reviews to that particular things, and if we ask what is the sentiment of the viewers, so viewers must say that movie was good or not, that movie was not good. So RNN many to one is example. There are many inputs but only one output. Then two important things are there, many to many and again many to many. But in both RNN term there is slight difference. One is a synchronous and another one is a non-synchronous. So synchronous have means if we are giving three inputs and we are capable for generating three outputs, means that is the synchronous type or synchronous type of sequence to sequence modeling, like a tagging for the parts of speech. And one more thing is there, many to many, that is a unsynchronized pattern. Means if we are giving a n number of output and we are not generate, if we are generating more than n number of output or n number of input or less than n number of input. For example, translator. If we give a translator, uh, for example, I like mango, and a translator will translate that thing into मुझे mango बहुत पसंद है. So in that term, input is a different and output is a different. Means synchronization is not there. Is in synchronization term, whatever inputs we are giving to that particular architecture, they are developing a output more than that input or maybe less than that input. So that many to many sequence to sequence modeling architecture or structure is commonly used for the development of a large language models. So now we see the history of sequence to sequence model and the how GPT will come into existing. So there are broadly five stages are there for the development of generative AI model, particularly language-based model, basic model I am considering over here. So that sequence to sequence modeling or for the development of GPT having a five important stages. Number one, encoder decoder model. Number two, attention model. Number three, transformer model. Number four, transfer learning model. And number five is the LLM U fit we are using there. So number one is the encoder and decoder. These are the that is the most common thing used in the early of two, 2012 to 2014 for the translation purpose. So in encoder and decoder, what we do, so this is a basic model for encoding and decoding. So we give inputs. Inputs are given to encoder, and with that state that decoded into some output. So whatever inputs we are giving to sequence to sequence modeling in encoder, same way output will be generated. But in that encoder and decoder, whatever inputs we are giving, so depending upon the context, at the end of what that sentence give a context. According to that context, decoder will decode that message and convert into particular things. So in encoder and decoder model, if the sentence is small and the sentence is short, then only that encoder and decoder model are capable to develop a good result. So this was the encoder and decoder model is the one of the pioneer steps of our computer engineering. Here sequence to sequence learning with neural network by Ilya Kustu Square was developed means give that research paper for the training of for the development of foundation model. Here he used LSTM technique, long short term memory concept for the encoding and decoding purpose. But in that in that technique there is a one drawback. The techniques are only capable for developing or converting a small sentences. If we are giving a very big sentences, then that models are not capable for convert that meaning in a proper way. Means not capable for decode in a proper way. See, that is the laguna of our first model. Means first step of our sequence to sequence model, encoder and decoder model, and that model come into the existence in the span of 2012 to 2014. So to overcome that problem, one more concept get introduced in the span of 2014 to 2017, that is the attention model. So in attention model, instead of uh, uh, dealing with the context, whatever the context generator at the end of that particular sentence, the decoder will not decode the meaning. Instead of that, in attention model, what they did, they give a context to every words of encoder and decoder, and they with the correlation of encoder context of each word and decoder context of each word, that encoder decoder model work and capable to develop a proper translation and proper things over there. So here I am just giving a overview of all those models, having a lots of mathematical approaches are there, but because of time constraint, I am just giving you a overview. I am not going in depth how mathematically that model will work. Just I am giving a overview because our today's topic is ethical consideration of AI and what are the impact in our data science healthcare because of time constraint. So in attention model, the context is given to each word. In simple way, if at the input side we have a five words and at the output side we have a five words, so each word having a different context, and that context with correlate with the input and output, and depending upon the proper analysis, that encoder decoder model will translate that thing into proper term. So the what is the problem in encoder decoder model? That problem is get solved in attention model, and attention model is capable for generating a good result for the big sentences having n number of words, 100 word, 100 to 150 word. But problem arise in that attention model as there are n numbers of words in input side and n number of words in the output side. So whatever mathematical calculations are there, n into n means 100 words are there input, in hundreds words are at output. To generate a proper real, there is a computation of or probability of 100 into 100 is there. So the computational time will take for the encoding purpose or encoding and decoding purpose is too much. Because of that, that model is not capable or time consuming things is there. So to overcome that problem also, in 2017 one researcher give a concept of transformer, that is a attention is all you need. This is one of the very best paper of this generative AI domain, developed by Google Brain team in 2017. So in this model, transformer model, they not use LSTM parameters over here. Here they use attention model in both encoder and decoder, along with attention layer, normalizing layer, and other parameters they added over here. So here these transformer models are capable to work simultaneously on the n numbers of words. So whatever problem is there in attention model, that problem get overcome in a transformer model is capable to analyze and do give the output, because in a short time, because transformer model parallelly capable to work on the n numbers of words over there. This is the general structure of transformer model, most commonly used in our nowadays generative AI foundation model. So transformer is the one of the good step came into the uh, generative AI development foundation model. After that, transformer model are good and they are capable to generate results in a short time, and they are capable to work on the multiple means huge data simultaneously. But transformer model, when we learned or develop any transformer model, what we required a huge data sets over there. Again, computational facilities we required good. So such models and such good models are only capable to develop by a good company like Google, HCL, or big companies over there, because they only have that much amount of computational facilities with them and database with them. So that models are not easily used by the normal persons and normal peoples or normal companies. So to overcome that problem in 2018, again the concepts come as a transfer learning concept in 2018. So in transfer learning concept, what they did, this is a paper get published in 2018, Universal Language Model Fine Tuning with Text Classification. Here, what J, Horvath, Jeremy Horvath will did, instead of using attention model, LSTM, he used two stages training parameters over there on the basic model. Number one is a primary training, and number two is a fine tuning. So the concept of that transferable learning is very simple. If if we are able to cook dal fry, then we are easily able to cook a dal tadka. Or if we are able to drive, if we learn to drive a bicycle, then we can easily drive the bike also. So same concept used over there in transfer learning. So in transfer learning, what they did, they give a database to transformer, and transformer architecture will train on that particular database, means on a language database, in simple way. So transformer model are capable to learn the various parameters of language, basic concept of language. Then that model is capable for the prediction of next works. Suppose example, I love Maharashtra and capital of Maharashtra is Mumbai. So that things next word prediction model is there. If we learn that transfer model on a language, so in transfer learning, what they did, they train that architecture on a particular model, and say, by training that model on the particular data set, that transfer or that model is capable for is okay with the all concepts of language, then that model can capable for giving a various results. Means if we ask any question to that particular model, that model having a all the concepts of language, that model give answers of that question. If we ask give any sentence to that particular model and if we ask what is the sentiment of that particular sentence, then that model is capable to give whether the sentiment is positive or whether the sentiment is negative, means sentiment is happy or sentiment is sad. So in this term, the basic models get learn on the transformer, on the various data sets, and transfer learning concepts get used in that particular sector, uh, and they are able to develop such more uh, foundation models. So after 2018, then because of the transfer learning concept in the domain of NLP, the huge impact will be there and shift will be there for the development of language models. And by using this concept, in 2020, in the span of 22, the researcher used a basic model transfer, like transformer model. Generally one research paper is there, LMN UFIT research paper is there, that researcher predict one model having a concept of transformer and transfer learning. Then they learn that model or train that model on the huge data sets of our domain, means data sets of Wikipedia, uh, Wikipedia, then IMDb database, then sport database, or whatever this database freely available in the domain of internet. They train that model on that particular database. Means pre-staging will be done over there, and for fine tuning, classifier will add over there for fine tuning purpose, and according to that, result will be checked, and one model is developed, and that model is considered as the language large language models. And after that, by using that large language model in 2022, Google will launch one app over there, birth, and OpenAI introduce one model is GPT, and if simultaneously research and other thing, GPT-1, GPT-2, DALE concepts get evolved over there. So in such way, language model get introduced, and that language model will develop for the further things, and GPT get evolved over there. Then after GPT get evolved language model, one more model will added over there, that is a vision based model, by using the CNN architecture over there along with RNN architecture. Then GPT model now capable to generate an image and anything. So this is the one model, language model. Same way there is a Jan, uh, Ja- Jan model is there. Generative advisor network, that model work on the basics of the images. By using this thing, we can able to develop a good images, and this also get introduced in the year of 2014. Means here, this is a simple block diagram of Jan. Generator is there, sample, discriminator, real image. So we give inputs to generator then develop one image according to our input, then discriminator will verify that image generated by the generator with the real image, and if that image is matched perfectly with the real image, they will get give a output, or otherwise this process is continuously going on for the development of perfect image till we accept that image. So again, in this chain also having lots of research things and lots of architecture is there, because of time constraint, I am not going details of that gen. So how all those things are now impacting healthcare sector, because we have a generative AI, but how that generative AI help in a medical sector? So generative AI have a n numbers of opportunity. Generative AI can use in a healthcare sector, finance sector, retail sector, art sector, or any sector of our industry. We can nowadays use a generative AI. But for particularly considering healthcare, now data science. So models, architectures are there, and architecture are capable to work on the specific task. But for training purpose, we require data. And if we train any model on the data of healthcare, then that model is capable for giving the more answer and more queries of healthcare sector. So why data science important in healthcare? The healthcare industry generated huge amount of data every day, include medical record, test results, and whatever test we conducted, like a eco test and other tests, means data from the wearable devices. So if we analyze such data and we work on that data, so that model is capable to predict the according to history of that patient, which type of proper treatment that patient required, according to disease parameter, which type of medication that patient required, whether according to his continuous record of visiting to doctor, that a patient required to admit in the future upcoming days, if that is the possibility is there, then what type of preventive action we can take to minimize such things. So such things can be done by using the data of healthcare in our generative AI system. So applications of data science in healthcare, number one is a predictive analysis, number two is a neutral language processing, number three is the machine learning, then computer vision, precision medicine, then clinical decision supports. I elaborated all those things in my upcoming slides. So number one is the predictive analysis. So generative AI can capable for the predictive analysis, means for example, predictive analysis can be used to identify patients who are at the risk of readmission to hospital. Means according to, if that database having a proper history of that patient, then that generative AI or that software can capable to predict his further illness or his chances to getting a hospitalization. Same way, analyzing historical data on patient medical history, previous admission, can create a model that predict which patients are likely to be readmitted. Then this information can be used to intervene early and provide additional supports to patient, reducing the likelihood of readmission. So if we have a proper data from the medical sector about the particular patient, so we can able to do a predictive analysis of his treatment or of his illness. Number two is the applications of data science in healthcare, precision medicine. So AI is very smart. AI can generate anything. Suppose, for example, if we ask to AI generate the references for the particular topic, AI can generate references for the particular topic, whether that references available is there or not available there. Same way, if we ask AI for the medication of particular illness, then that AI is capable to give a medications or whatever medicines required for the particular illness. But whether that medicine is accurate or not, we don't know. But if we train that architecture on the data sets of medical, then that particular model or particular generative AI app is capable to give a proper medicine to patient depending upon his previous history of illness. So by using that data sets, we can develop a app for the precision medicine. Precision medicine involve tailoring treatments to individual patient based on their genetic and other data. By analyzing large amount of patient data, data scientists can identify genetic markers that are associated with the particular disease or condition. This information can be used to develop personalized treatment plan that make account of each patient unique needs. So nowadays such apps are in market because most of the people want to reduce their weights. So they are asking what is your height, what is your existing weight, depending on they are suggesting one treatment. You follow this diet. So after 6 months of span, your weight get reduced by that much amount. So such type of precision things we can provide it by using the generative AI concept and by training a data sets of healthcare on that particular model. Then clinical decisions and support, one application is there. Then electronic health and records, generative are capable to maintain a proper records of patient, including their diagnosis, treatment, whatever test results are there. If we all this term, I am talking about whatever model we discuss it now, that is a language, large language learning model. But now the medical sector having a huge database, and generative AI also explore in a tremendous way. So nowadays CT scans are available there, X-rays are available there, and n numbers of reports are available there. So we are capable to generate such a, a app by using a technology of image processing. Suppose if we have sonography reports, we have X-ray reports. So X-ray reports of fracture. If we get a database of X-ray of various fractures, and according to whatever treatment earlier provided for the previous fracture, we train that model on that particular database. So by just sending image to that particular app, that particular app did the image processing of that X-ray and able to predict the remedial for that particular disease. Same way, heart attacks problems are there, brain tumor problems are there. If we give a such, if we train that our image-based model, vision-based model, or develop a vision-based model by you giving a data sets of X-rays, by giving the data sets of brain tumor, by giving the data sets of sonography, whatever reports are generated in pictorial way. So by using the concept of image processing, that app or generative AI app are able to predict the remedial actions over there and suggest a number of things for particular things. Then challenges of data science in healthcare. Number one is the privacy and security. As every patient having a different history, and that data is very sensitive and unauthorized. If we have a history of any person, and if we train that model on that particular history, and if anyone asks about the details of that particular patient having some diseases, so that things are very accessible to everyone, that may cause impact the privacy and security of that particular patient. Same way, data quality. If we Healthcare data is often complex, messy, and incomplete, which can make it challenges to analyze and interpret. So, whatever data we got, if the data is not authenticated properly, data is very complex. So, if we teach that model on that the complex database or in quality data, so our results are also developed in that term. Same way, biasness is there. Data science model can biases and inequalities if they are not designed and implemented carefully. If we feed a biased database to our model, generative AI model, that model will develop such a record. If in the term of races, we learn that basic model to develop a result. So that model, if we give a input, height is 2 feet, तो डेटाबेस मॉडल को अपन ने बता दिया 2 फीट हाइट के लोगों को अच्छे नहीं होते, वही प्रॉब्लम होता है. सो that model will always develop such results having a height and having a weight of that particular thing, because data generative AI differentiate नहीं कर सकता. Whatever we train, according to that, the generative AI will develop a result. So last part of my uh, deliberation is the ethical consideration. Number very important thing in when we are using data science or generative AI, biasness and fairness is there. So that's why it is very important to teach any generative AI model on the huge data sets to overcome the problem of biasness. If one example is there, if we develop any hiring app, and with that hiring app we give a data having some biasness, means only means as per the overall review, these height peoples are good, the white peoples are good, then slim peoples are not good. So such database is fit to that particular AI when that AI model is developed. So if any resume will come under that parameter, whether that candidate having a good qualities, then still that app having that teaching of database, so that app will reject that particular application instead of checking the qualities of that particular resume. So biasness is there. Then security and privacy. Nowadays, image processing concept is there. If we train any vision-based model on the image, if we want to give a access of particular thing, particular area to any person to use that area. So on scanners, on camera, face detection is there. Nowadays AI apps are very smart. They can, by using Jen's concept, they can capable to generate a exact image of anyone. So exact image is developed over there, and that image is used for the use of that particular secure area. Then anyone can fool the generative AI system. So security is the one important concept is there. Then misleading is there, because most of the time generative AI hallucinate us, because generative AI train on a massive database. So the generative AI capable to generate any result. So if we ask to generate a reference for anything, if we write to ask a research paper on any term, generative AI will write a uh, research paper on that term. In nowadays, I am a dean at USA, most of the time I ask to faculty members come up with the proposal. So they just give instructions to AI, generate a proposal for the conduction of 2 or 3 days workshop. Instead of seeing what parameters we are considering over there, generative AI will develop a one good excellent format for the conduction of any proposal format for the conduction of 2 days workshop, but that things are added over there are the generalized misleading that are not useful for the our purpose. So that things are there, so ethical consideration we have to consider over there. Then sometimes generative AI will give a privacy get security will get disturbed, means in what term? If we ask how to develop a bomb, and generative AI is capable to give an entire methodology for the development of bomb, so such results not to be developed by generative AI. So this ethical consideration will take who will take care of this ethical consideration? So the person who are developing that app or that model, or that person who are doing a fine tuning or pre-training of that particular model on that particular database. So these are the some ethical consideration we have to consider for the development of any foundation model for the generative AI purpose. So these are the chat box also you can develop for healthcare center. So if doctor is busy and if we train that model, and on the particular database some doctor is specialist in heart, whatever the heart data heart related to heart disease data the doctor have, he can train that model on that particular database, then he develop use that model for the chat box, then chat box is capable for give us some type of sort of answers to that question. So we can use generative AI for the development of intelligent chatbots and for virtual assistant. But all these are come under the category of domain specific. These are not a generalized system or generalized generative AI model. Same way, pharmaceutical and biotech researcher can use the data for drug discovery, molecular design, and predictive modeling. So AI and data science having a huge impact in every sector of our life. So how we are developing that foundation model, how we are training that model depending upon the task specification, we can develop such results. So for further research, anyone want to do a research in the development of particular app for medical sector, he can collect data data in two terms: supervised data, unsupervised data. Generative AI, you work on the unsupervised data because generative AI develop a database from any information. If we are give a PDF, generative AI will develop a database from that PDF. That means we consider it as a label database. But for generative AI, that is a unsupervised uh, data set, and he that generative AI capable for the generation of result. So in health sector, there is a tremendous work in this particular domain, and we can develop the app by using generative AI and the data of healthcare for further research. So I stop here. Thank you. Saira ma'am.
Yes, sir.
Okay, I finished my deliberation. If anyone
Yes, sir. Yes,
having
sir.
any,
The session has come to close. Are there any queries the participants would like to discuss with our expert? Are participants having any queries to discuss or any questions to ask with the expert? You can type your message in chat box. Yes, ma'am. We will share PPTs later. Okay, so I request all the participants to please fill the feedback form shared in the group chat. Now, thank you, Professor Ritesh Banpurkar, for sharing your expertise with us. Your lecture was highly informative and helpful. It was incredibly enlightening. Thank you, sir. With this, we come to the end of our day one session. Thank you all for your participation. Now, we will continue the session at tomorrow from 6 to 9 p.m. You can join the session through the same link. Before leaving, I request all the participants to please give your feedback through the link which I have shared in the group chat. It is mandatory. Thank you.